Hope the screen is visible.
Yes, sir.
Okay, nth order LDE with constant coefficient. Aim is to solve this. Right now, so general solution is y equal to y of c plus y of p. Right? For the complementary function, 4 formulas are there. Okay. Whereas for the particular integral, yes, how many methods are there? 3 methods are there. Okay, general method. Okay, next is the shortcut method. And then method of variation of parameters. Now, what about shortcut method? Shortcut method is known for this type of functions: e raised to ax into a raised to ax constant. Okay. Second, sine of ax, cos of ax, sine hyperbolic of ax, cos hyperbolic of ax. Okay. Then we studied polynomial, say x raised to m. Okay. Then we studied shortcut method for e raised to x into v. And then x into v, where v is any function of x that we know. Okay, so shortcut method is known for this type of functions only. So suppose we have f of x equal to e raised to x. Then shortcut method is not known. Suppose we have sine of e raised to x. Shortcut method is not known. Okay, suppose we have 1 upon 1 plus e raised to x. Shortcut method is not known. Right? Shortcut method is not known for this type of functions. No shortcut method. Okay? No shortcut. So whenever shortcut method is not applicable, then we have to try to use the general method. Now, what is the restriction on general method? Two restrictions are there. One, roots of auxiliary equation should be, yes, anyone? Can anyone complete this? Should be real numbers. Right? Then only we can use the general method. If complex numbers are there, using general method is very difficult. Right? And integration is involved. Integration is simple, or we can solve it. These are the two restrictions. So whenever roots are not real numbers, right? When in general method roots are complex numbers, above method is used. समझ में आ रहा है ना? Everyone is getting this now. What is the difference between them? So first you try to use the shortcut method. Okay. Now, if it is not possible to solve example by shortcut method, when it is not possible, if this type of functions are there, e raised to x, sine e raised to x, 1 upon 1 plus e raised to x, or any function which is different from whatever we have written below the shortcut method. Tan x is there, okay, log x is there, then we cannot use the shortcut method. Okay, then we have to try, then we have to check whether it is possible to use the general method. Now, when we can use general method, whenever factors, or I will say roots of the auxiliary equation should be real numbers, and the integration, corresponding integration is simple. Else you can go for the method of variation of parameter. Okay, so whenever general method, in case of general method roots are complex numbers, then we have to use the method of variation of parameter. Clear? Understood? इसमें कुछ डाउट है? कुछ डाउट है इसमें? क्या डाउट है सांगा? Can I proceed? I am audible? या आप जो करना है करो, हम जो करना है करते हैं. What is it? Any doubt here?
No, sir.
No doubt. बोलो यार, कुछ नहीं बोलोगे तो समझ में कैसे आएगा. चलो. So first part we have completed. 2/3 part we have completed. How to solve the linear differential equation with constant coefficient. Now there are few differential equations which can be converted into linear differential equation with constant coefficient. Okay, we want to study them. Okay, so right, differential equation. Let me change the page. Change the page. 1 minute only. Sorry. Right, differential equation. Differential equation reducible to linear differential equation with constant coefficient. Two are there. Let me start with the one, right? Cauchy's or Euler's. Homogeneous linear differential equation. Okay, it is of the form d raised to n minus y divided by dx raised to n minus y plus a2 x raised to n minus 2 d raised to n minus 2y dx raised to n minus 2 and so on, plus a n minus 1 y equal to some function. क्या प्रॉब्लम है इसमें? What is problem here? Is the problem with a1, a2, an minus 1? an minus 1 या an आएगा लास्ट में, an आएगा. an, हाँ, लास्ट टर्म इज a. अच्छा, इसमें क्या प्रॉब्लम है? What is problem in this differential equation? Yes, can anyone tell me what is problem over here? You can attach a note also here. What is problem in this differential equation? Can we solve it by the shortcut method? Can we find the particular integral by shortcut method? अरे बताओ. What is required? Linear differential equation with constant coefficient required, na? See the coefficient x raised to n, x raised to n minus 1, x raised to n minus 2. Okay, that is to be removed. Getting everyone, na? Nada. Here, the coefficients of derivative term are not constant. पानी आहे, एक अर्धी बॉटल दे चल लेक्चर सुरू आहे. ठीक आहे. Coefficient of derivative term is not constant. Okay, so let z equal to log x. So now we are replacing x by z. Z equal to log x. So what will be x? X will be e raised to z. Okay. Now see what I am doing. I am writing dy by dx. Tell me what is dy by dx in terms of z. Dy by dz into dz by dx using the chain rule. Right. Now since we know z, I'll write it here. Since z equal to log x, tell me what is dz by dx. What is derivative of log x? 1 upon x. Okay, so let me use that. So dy by dz into 1 upon x. I'll take x on other side. So x dy by dx equal to dy by dz. So x d by dx of y equal to d by dz of y. Okay. So what the operators are? Operator is x d by dx. That can be replaced by d by dz. Time being, let me consider it as equal to capital D. Right? I'm considering d by dz equal to capital D. Huh? So in the same way, what will be x square d square divided by dx square? You can cross check it. That will be equal to d minus 1. Okay. Then what about x cube d cube divided by dx cube? That will be equal to d minus 1, d minus 2, and now so on. Okay. Now we have to substitute all the values in equation number 1. Okay. So let me write on next page. Written. Substitution is z equal to log x. And from there we got x d by dx. You might have understood that. See here. Here. Correct, na? See this. The coefficient on the left side is x, whereas coefficient here is 1. So convert it into constant coefficient. See the next. Coefficient is x square. Here coefficient is 1 and minus 1. Right? Same for the last one. Coefficient is x cube, and then on the right side the coefficient is some constant numbers. Clear? So using this substitution, we have converted the differential equation into differential equation with constant coefficient. Okay, let me change the page. Right, using, we can write it on the previous page, but now it's not possible. Right, using above substitutions in 1, it is reduced into linear differential equation with constant coefficient in y and z. Okay, so instead of x, we have now z. Solve the differential equation by usual method. Then right. Finally, replace z by log x. So final answer should be in terms of y and x. Right. Note. Final answer should be in terms of x and y. 1. We'll go through example to understand this. Okay, so time being, you just remember that the given differential equation is linear, but not with the constant coefficient. Okay, and we want to make the coefficient constant. How? We'll understand. Right? Solve. I'm audible?
Yes, sir.
Okay, d square y divided by dx square Is it Cauchy's homogeneous differential equation? Compare that with the differential equation we written before some time. क्या लिखा था हमने? a नॉट x रेज टू n d रेज टू n, x रेज टू n d रेज टू n दोनों के पावर सेम थे, therefore it is known as homogeneous. Next it was x raised to n minus 1 d raised to n minus 1. Is it so in this differential equation? No. See, x cube and d square is there. Okay, so what should be the first step? Pradam. Dividing by x. Now the powers are same. Write this as 1. 1 is Cauchy's homogeneous LDE, linear differential equation. What is the problem with this differential equation? These coefficients. We don't want this x cube, we don't want this x. That is to be removed. Okay. So let x equal to e raised to z or z equal to log x. Okay, therefore the differential equation will become x d by dx. It will become, yes, capital D, x square d square divided by dx square. This will become what? D minus 1, right? Where d equal to, ये d क्या है? d by d x और d by dz, d by dz, इसको समझना है, हाँ याद रखना है. Therefore, see now, equation number 1 will become x square d square divided by dx square. What is this? Written here. Written here. Okay. D minus 1. And then y is there. Plus x d by dx. यहाँ पे. That is equal to d. So 3 as it is. D we have to replace and then y. Plus y equal to 1 upon x. So 1 upon e raised to z. Sine of log x, that is z. Okay, simplify करो इसको. So taking y common, d square minus d plus 3d plus 1 y. So d square plus 2d plus 1y this is not solution, this is only conversion. Understood up to this step? Now see the coefficient of d square 1, coefficient of d 2, coefficient of y 1. Are they constant? Yes. Whereas in case of given differential equation, the coefficients were x, x square, x cube respectively. Are I सबको समझ में? Everyone is getting this? Okay. So we converted it into linear differential equation with constant coefficient. अब इसको solve करना है. We know how to solve it. Okay. Our usual method. Okay. So can I change the page?
Yes, sir.
Our number is very less. Only 28 people are here. Half of the strength of class. क्यों कुछ पढ़ने का इरादा नहीं है क्या? बाकी लोग किधर गए? तेजस है क्या?
Yes, sir.
तेजस का क्लास सीआर वगैरह चेंज करना है ना?
नहीं सर.
अच्छा ठीक आहे. कुठे गेले बाकीचे? जिओलॉजीच्या लेक्चरला किती होते स्ट्रेंथ?
22 absent होते सर.
किती? 20?
22 absent होते.
ओके. मस्तच भारीच आहे बाबा सिव्हिल इंजिनिअरिंग. ओके चला ठीक आहे, काय हरकत नाही. चलो लेट मी चेंज द पेज. नाउ वी वांट टू सॉल्व द डिफरेंशियल इक्वेशन. चलो सॉल्व करूया. डी स्क्वेअर प्लस 2d प्लस 1. जरा you tell me this differential equation. I want to write it on the next page. If anything is wrong, let me know. D square plus 2d plus 1y equal to e raised to minus z sin z. I think it is correct. Right? General solution is first part is to find complementary function. Auxiliary equation. Real and repeated root. What the y of c is? C1 plus C2. It is not x, huh? Z. E raised to minus z. Okay. Right, in terms of z, we removed x. Hope you remember. Capital D is d by dz, na? It is not d by dx. Then particular integral. So whenever we want to find a particular integral, first we'll think about the, yes, which is the simplest method, shortcut method. So we'll see whether it is possible to use the shortcut method. Yes, can we use shortcut method? इसको shortcut method से solve कर सकते हैं क्या? अरे बताओ. Can we use shortcut method? Anyone? Yes. अरे कुछ तो बोलो. कौस्तुभ, can we use shortcut method for this? पढ़ते हैं या नहीं? चिराग सोनोने, can we use shortcut method? Harshal Raut, can we use shortcut method? Nitan, कुणाल, अरे काय बोलायच नाही ठरवलं काय? ओम वाघ, रोहन पाटील, सिद्धेश, सिद्धेश, सुजय. Don't know, sir. Why don't know?
Yes,
Already
sir.
we studied it now. Sriyash,
Yes, sir.
Kayes. Kayes. Can we use shortcut method?
Yes, sir.
कोणता फॉर्म्युला सांगा? अरे you remember this or not?
Yes.
याद है या नहीं? D is to be replaced by D plus A. So here it is D, coefficient of Z, -1, so minus Z. So y of P equal to e raised to minus Z on this side. Now can we use shortcut method for sin Z? Getting everyone? Okay, let me change the page. Written everything? Have you written everything?
Yes, sir.
Okay. This is the general solution, but it is in terms of Z.
Hello, sir.
Yes. Continue. So yes, बोला.
तुमचा आवाज येत नव्हता.
अच्छा अच्छा. हाँ बोलूच नहीं क्या. This is the answer. We replaced z by log x, and e raised to minus z is 1 upon x. That is x raised to minus 1. And then minus sin log x divided by x. Hope everyone is getting this. Clear? Can we go through the next example? बढ़ सकते हैं आगे. Second example. Solve. Log of x whole square minus log of x square. Right. Cauchy's homogeneous linear differential. X square d square x d. Okay, so it is homogeneous. D is d by dz. Okay. Therefore, the given equation 1 is what is log of x square? Minus 2 log x. Log of a raised to b is b log a, na? This formula is used, and therefore we have sorry is z ಇದೆ. z square minus 2z polynomial. Can I change the page?
Yes, sir.
Understood? Let me change the page. Check whether it is correct or not. Sure, right? Y of c plus y of p. Check this. Hope everyone remember the shortcut method for polynomials. Correct? 2 is taken outside, so that we get 1. And then a minus sign is taken common from the remaining two terms. And use this formula.
1 minus t square.
Correct.
1 plus t square plus.
Yes, use this formula and solve it. Do it yourself. So 2 minutes are there. Anyone got the answer? T. Next is T square. T cube. What is first derivative? What is second derivative? What about third derivative? 0. Y terms up to d square only. D cube is 0. D cube of this term again. Now, if you square this, a minus b square, what is a square? Next term will be d cube term, d raised to 4 term. They are not required, so I am not writing them, huh? Add these two. Okay, आ रहा है सबको समझ में? Everyone is getting this? क्या difficult लग रहा है? चलो, I'm audible ना?
Yes, sir.
Okay, so let me change the page. Now I'll operate this 1 plus 3 by 2d on the z square minus 2z. 1 into the term. Derivative. First derivative 2z minus 2. Second derivative 2. What about next? 0. Remaining derivatives are 0. So not written.
सर तिथं
Yes.
3 -3 येणार ना, -6च्या जागेवर -3 येणार.
हाँ, yes. इतना
येस सर.
-1 by 2. Yes. E raised to z is x. What is e raised to 2z? X square. This is the solution. Got it. Understood. Next. आ गया ना सबको समझ में? Can I change the page? चलो चेंज करता हूँ. Right. Legend rays. Linear differential equation. Right. Differential equation is of the form a naught ax plus b raised to n. So it is not homogeneous, huh? For homogeneous, what is required? The coefficient should be x raised to n, d raised to n, x raised to n minus 1, d raised to n minus 1. It is not so. It is ax plus b raised to n. Okay, so can anyone tell me what will be substitution? Z equal to, कोई बता सकता है क्या substitution आएगा? Yes. Om Danam, what will be substitution? What was substitution in previous case? Cauchy's equation. A naught x raised to n d raised to n y divided by dx raised to n. This was the differential equation, na? So substitution was z equal to log x. Now what will be the substitution? Z equal to what? Anyone? Same thing. Log of instead of x, x plus b. And therefore ax plus b will be equal to e raised to z. Getting that? One minute, huh? As we have done in the previous case. differentiating on both sides with respect to x. Let me take ax plus b to other side.
तर वरती a डिवाइडेड बाय ax प्लस b ने मल्टिप्लाय का केलं ते dz अपॉन dx च्या बाजूला.
ठीक है. dz by dx we obtain here, na? That is substituted here.
So yes sir.
This is operator. Right here in previous part, Cauchy's homogeneous linear differential equation, the coefficient of d was 1. Here it is a. And now so. Okay, below this down. Using above substitutions in 1, it is reduced into right linear differential equation and constant coefficient. उसको solve करना है हमें by our usual method. Replace z by log of ax plus b. Okay. Solve few examples to understand this. Let me change the page. So there is change of substitution only there, nothing else. चलो सॉल्व करते हैं. Right. Two x plus 1 square equal to 1 is linear differential equation, but with not constant coefficient. The coefficients are not non-constant. For that, we want to use the self-relation. Therefore, what is A here? A is the coefficient of X. Okay, so 1 will become. Are you writing all these things? Therefore, 1 will become, see this total value 4d minus 1 and then y minus 6 into 2d. आताच खालून आलोय तुमच्याकडे बघ यायला गेलो ते खाली गेलो आताशी सोडले त्याच्यात चुका निघाल्या जरा परत डेट चुकल्या 4 डिपार्टमेंटला पाठवलेलं कशाचे डेट ते फॉर्मॅट चुकलाय 1-1-8 वगैरे ते उलट झाले 1-8 ऑगस्ट 1 ऑगस्ट 8-1 माझे काय उलट आहे निमानी काय उलट आहे माझं काय काम आहे बघा मदत करा काय त्यांचं लेक्चर आहे त्याला बोलवा त्यांना नको जाऊ यांना या कोणाला दिला यांना या कोणाला 8 2x plus 1 that is e raised to z right square. Simplify this. I am taking y common. In fact, correct. Sorry. We can take 4 outside. This is the reduced differential equation. Coefficients are constant 1, minus 4 and 4. Okay, now write the general solution. I am audible. कौन है कौस्तुभ है सौरभ समझती कि नहीं रे साहिल साहिल पवार राजा समझती कि नहीं रे ऋतुजा समझ में आ रहा है या सिर्फ आप लिख रहे ओम दानम
यस सर
समझ में आ रहा है
यस सर
ओके लेट मी कंटिन्यू कहाँ पे जाना है चलो ओके चल आगे बढ़ते हैं right? C1 plus C2z e raised to 2z. Now I'll find particular integral. Particular integral part is also simple, not too difficult. Written? Can I go to the next page? Century will make a century on next page. Chalo, can I change the page?
Yes, sir.
Okay. Ah, 1000 is written. Oh, my mistake. 1000 is written. Okay. Replace. What is shortcut method for exponential function? Replacing d by a. Hope you remember. But unfortunately, it becomes 0. So use the second formula z. It is not x, huh? Z derivative from here.
So answer e raised to 2z.
E raised to 2z nahi re. First formula fails, so from here z, one more z square, derivative is 1 upon 2.
Yes, sir. E raised z square e raised to 2z.
This is okay. So general solution is but two x plus 1 square, then z square, that is 2x plus 1 whole square into log of 2x plus 1 whole square. This is the general solution. Got it? आ रहा है सबको समझ में? Everyone is getting this. One more example. Yes. चलो आगे बढ़ते हैं. क्या है एग्जाम्पल नंबर? Can I change the page? Okay. Right. Solve Write the question. X plus 2 x plus 2 cube. Here it is square, huh? X plus 2 square d square y divided by dx square plus 3x plus 2 dy by dx plus y equal to cos of log of x plus 2. So, okay. Let me write differential equation like this: x plus 2 square how we can write x plus 2 cube. Legendres LDE. Substitute. Z equal to log of x plus 2. So AD. But what is A here? 1. Coefficient of x is A, and that is 1. So 1 will be converted into after simplification. Minus d plus 3d, that will become 2d. Okay, let me continue. So we reduced equation number 1 to equation number 2. That was the important part. Now I'm audible.
Yes, sir.
Yes, sir.
Yes, sir.
Okay, y of c plus y of p. Minus 1, minus 1. C1 plus C2z e raised to minus z. Let me change the page. Okay, can I change the page? So now we have to operate 1 upon d square plus 2d plus 1 on cos 3 set. Yes, we'll see what we will get. Shortcut method formula for trigonometric function. Correct? 2 is taken outside. Hope you remember how to use the shortcut method for trigonometric function.
Sir, page.
अरे आधीचे पेज कुठे गेले? आधीच नाही. Just you try to solve the example. Some connectivity issues there. ठीक आहे, होईल असं वाटत नाही आता. ठीक आहे, चालेल. Stop here. Please solve the remaining part of example. Do it yourself. Let me take the attendance. Solve the remaining part of example.